This video will be about multiplying binomials. A binomial is an expression with two terms. 3x is one term, negative 5 is the second, or in the second parenthesis, x is the first term, plus 7 is the second term. So when you are multiplying binomials together, there's a couple different ways to remember this. There's the FOIL method, there's we call it the rainbow method, where you just use arrows to point. But they're all leading to the same thing of doing this first term 3x times the first term of the second set of parentheses, so 3x times x. Then you'd have to do the 3x times the 7. So 3x times x was first times first, that's the F for FOIL. 3x times 7 was the outside times the outside, because each one 3x is both the first and the outside. So 3x times 7 came next. Then we go I is inner, so negative 5 times x, inner times inner. And last times last, negative 5 times 7. So you don't necessarily have to write out this middle step. It can be helpful though, but you could just multiply it in your head and write your final answer. So 3x times x, if there's two x's, we write that as x squared. 3x times 7. 3 times 7 is 21, and we keep the x with it. Negative 5 times x, well that's really negative 5 times 1, because there's a 1 in front of the x, so negative 5, and we leave the x. Negative 5 times 7 is negative 35. Then, when you're at this step, if there are any like terms, we should combine them. Even though x squared and x both have x's, a like term has to have the same exponent as well. So 21x is not a like term with 3x squared, but it is a like term with negative 5x. When we combine them, we just add them together. A positive 21 minus 5 is 16x. And that would be your final answer for this first question. So a second type of question they give you is an area question. Find the area of a shaded region. So when you have a square or a rectangle, the area is just the length times the width. If the length was 8, we would multiply it by the width, which I'm going to say is 5. 8 times 5 is 40. We just multiply to get the area. It's the same idea here, but we have bigger things to multiply. We have to take this entire thing, x plus 3, and multiply it by x plus 5. That will give us the area of the entire box, including that empty space we don't want. But we'll worry about that empty space in a second. So first we multiply x plus 3 times x plus 5. First times first, x times x is x squared. Outer times outer, x times 5 is positive 5x. Inner times inner, 3 times x is positive 3x. And it's positive, so I should put a plus sign. 3 times 5, positive 15. And then we combine like terms. X squared plus, we combine the 5x and the 3x to get 8x. So x squared plus 8x plus 15. Now that's not quite our final answer, because we don't want this little box. We want that area to go away. When we don't want something, usually we subtract it. We take it away. But first we have to find the area of that little box using its length and width. We have x plus 1 times x plus 2. First times first is x squared. Outer times outer, x times 2 is 2x. Inner times inner, 1 times x is 1x. Last times last, 1 times 2 is 2. Combine our like terms, we get x squared plus 3x plus 2. Now we want this to be taken away. We want to minus it. So we start with our x squared plus 8x plus 15. And we want to take away which means we want to minus everything. Minus the x squared, minus the 3x, minus the 2. And then we want to combine our like terms. We have an x squared and a negative x squared. X squared minus x squared cancels each other out. They get rid of each other. We have an 8x minus a 3x. That gives us 5x, because 8 minus 3 is 5. And we have a 15 minus 2, which is a 13. So our final area of the shaded region would be this 5x plus 13. If they gave us an actual number for x, we could find the final number, but sometimes our answers are just expressions. We want the whole expression to mean the area. So the last topic on this section is multiplying a trinomial times a binomial. Now before we remembered FOIL, first, outer, inner, last, that won't quite work for this one, but we still can do this arrow method. I'm going to take the first term, 4x squared, and I'm going to multiply it by everything in the other parenthesis. 4x squared times 3x. That would give us 12. We have two x's here and a third one, so x to the third. Then we do 4x squared times the 7. 4x squared times 7. 4 times 7 is 28. There were only two x's. We didn't have another one to worry about, so 28x squared. So I am done with that 4x squared. It's multiplied by everything. Now I worry about the negative 2x, and I do the same process. Negative 2x times 3x. Negative 2 times 3 is negative 6, and there are two x's, so x squared. When you're multiplying, it changes the exponent. If we were combining like terms, when we're adding or subtracting, you just leave whatever exponent it is. But since we're multiplying, we change that exponent. Negative 2x times 7. Negative 2 times 7 is negative 14x. Then we do our third group. We have the 5 to worry about. 5 times 3x is 15x. 5 times 7 is 35. Again, we combine any like terms now. 12x to the third. I have an x squared, x, x, 35. I don't have any more x to the thirds, so we just leave 12x to the third. 28x squared. I have a 6x squared, negative 6x squared, but then just an x, and a number. So 28x squared minus 6x squared. 28 minus 6 is 22. This time you leave the exponent because we're adding or subtracting, not multiplying. Next we have negative 14x plus 15x. Negative 14 plus 15 is a positive 1, and you leave x. Now most likely they're not even going to write the positive 1 in though. Really they'll just write x. You can assume there is a 1 there. We call it our invisible 1 sometimes. So usually we just leave it x. And then 35 also didn't have anything to combine with, so we leave it as positive 35. So that concludes our discussion about multiplying binomials.